So today we're going to continue talking about radian degree measure. We're going to do a little bit of conversions today, converting from one form to the other, which is beneficial with some means, especially if we're trying to solve a problem that has to have an angle value in radians, but they give it to you in degrees, so we need to know how to convert it from one to the other. And then we'll also talk about very specific angles. Jenna, what number was that I was talking about? The one that had like the 35. So number 35 in the homework had 130 degrees and 52 minutes after it. It had like an extra piece to it. That's a very precise angle. So it's an angle that's between literally like 132 and 133 degrees. So we'll be talking about those precise angles today as well. But degrees works like a clock. It works like time. So they have the same base. Like that's 60 minutes in an hour kind of thing. So we'll be talking about that today too. So today is like conversions, not really focusing on sketching the angles, but more how can we create a radian if you have a degree value, in hopes to start helping you kind of get those angles into your head as they go back and forth. You may have a quiz tomorrow. It kind of just depends. We'll see. Maybe. But I really want to make sure that we have time to thoroughly talk about like how the 30, 60, 90 triangles, 45, 40, 95, 90 triangles that you just took, how they create points on a circle that correlate with sine and cosine. So that really is the goal tomorrow. And I want to make sure we have enough time to thoroughly talk about that and not like rush through it. So probably quiz on Monday and Tuesday. We'll see about tomorrow. If we do, it'll be at the end of the period. So the top part of this page is talking about 1 degree and how 1 degree is really 1/360th of a complete revolution about the vertex of a circle, which makes sense because if a circle has 360 degrees, one of those 360 degrees would be 1/360th. So the reason we need to think about that is because to try and think about converting from a degree to a radian, we need to remember that the 360 degrees creates a circle. So underneath, we have these two values that we've created yesterday. So we said 360 degrees is a full revolution or rotation, however you want to think about it, around a unit circle, which is the same thing, or around a circle. It's the same thing as 2 pi. So if I spin around a circle, you've spun 360 degrees, or in radian measure, you can now say, hey, I went 2 pi radians. People would probably look at you crazy if you did that, but hey, why not? The next one, 180 degrees is equal to pi because 180 is half of 360, pi is half of 2 pi. So taking that information into account, we can then say that 1 degree is pi over 180 radians. Because if we go back to this fact right here, where it says 1 degree is 1 out of 360, and also apply this fact right here, 2 pi is equivalent to 360 degrees, which is therefore equivalent to 1 degree. So if we simplify this, instead of saying 1 degree is 2 pi out of 360, we could say 1 degree is really the same as pi over 180 radians. And then flip-flopping that, 1 radian is equivalent to 180 over pi, because it would be kind of the opposite thinking. So 1 degree is pi over 100 radians, 180 radians, or 1 radian is 180 over pi degrees. So a radian is a little teeny tiny piece of the entire circle. A degree is that same teeny tiny little piece of the entire 360 degrees. So there's a big gap underneath. And in this big gap, we're just going to draw a circle and try and work our way around talking about some of the important angles of a circle. So you have a nice space. Draw yourself. Oh, that looks all right. So draw yourself a nice circle. Move mine down a little bit. So So there are angles that we refer to as common angles on this circle. Those common angles, tomorrow we're going to correlate or match with a degree or a radian value. And if we just draw an XY axis in the middle, our first angle would always start at 0 degrees. So that would be our first angle. There are 3 angles that are associated with the special right triangles besides 90 degrees. And those angles would be 30 and 60. Those create the 30, 60, 90 triangle. And then our 45-degree angle would be in the middle of those two and also in the middle of 0 and 90 degrees. So those 3 angles create the rest of the common angles that we will use in the unit circle. And there's a little pattern to get you to remember them. So if you look at the distance between each of these, we're increasing by 30, 15, 15, and then 30. So the increase of the angle as it's working up, you're adding 30 degrees, 15 degrees, 15 degrees, and then you're adding 30 degrees. So if we want to find the common angles that are in the second quadrant, if you apply that same pattern, then we can then start to list the common angles that will occur in the second quadrant. So Brandon, if we have 90 degrees and we apply this pattern of 30, 15, 15, 30, our next angle would be 120, and then add 15,
135,
add another 15,
150,
and then add 30, and we're halfway around at 180. So these are common angles that are in the second quadrant. They're the same relationship as the one in the first, because we're using that same pattern. So all the angles we work with will either be a 30, a 45, or a 60-degree angle. So then if you continue that pattern, Libby, if we continue working in the third quadrant, adding 30 would give us
210.
15,
225.
good, and then 30 would be, I'm sorry, another 15, sorry, my fault.
Wait, you messed me up.
30, 15, so we need to add another 15, that's fine,
240.
there you go. And then another 30 to that takes us to 270. So then finishing the fourth quadrant with our final group of angles that we'll kind of look at and associate with. Chelsea adding another 30 gives us 15, another 15, and then we round out the circle with 360 degrees. So tomorrow we'll then take these common angles, we'll associate them with a radian value, and then we'll start actually creating points. Because where the angle meets on the edge of the circle is an ordered pair if you're thinking about a graph, x, y. So I have an x value and I have a y value that I can create to get up to that point. And that's how that, like the circle on the front of the yellow packet, like that's how this is starting to be created. But there's patterns in it. So like when I say you have to have it memorized, if you can memorize 30, 15, 15, 30, that pattern takes you around the circle to create your angles. So these are commonly used angles of the circle. Underneath, we're going to see if we can try and convert some of the commonly used angles to radians. So we know the degree values, how can we start converting them to radian values? And the method to do that, the first one says to convert to radians, so we want to get radians. We're going to multiply by pi over 180. And we can do that because 1 degree is equal to pi over 180. So if I want to try and take a degree and convert it to a radian, we can multiply it by that conversion. If you want radians, whatever you want, you need on the top of the fraction. Whatever you want to get rid of, that needs to be on the bottom because that's what we're dividing out. A little bit like stoichiometry, which I know you guys don't like very much. It's a little bit like that, but not a lot. Just a tiny bit. Just a small conversion. So if we have 135 degrees and we want to convert it to radians, that means we want the radian in the answer. That's the pi part. So a radian is like that, a value that usually contains pi. We want to get the degree out of it, so we'll divide it by 180. All right, so this is a little tricky. 135 and 180. We need to think of something that they have in common. Michael, do you know what we could divide them by?
5.
So we could divide them by 5. So what's 135 divided by 5?
Like, is it 27?
Yeah, it is 27. And 180 divided by 5.
Um,
36. Chelsea. And then we can divide by 9. So Chelsea, 27 divided by 9 is? And 36 divided by 9 is 4. So 135 degrees is actually 3 pi over 4 as a radian value. So in the circle, tomorrow we'll start saying, all right, well these guys are equivalent. 3 pi over 4 is 135 degrees. And I'll show you a way to also kind of memorize all those values too. There's a whole bunch of little tricks in it. So looking at the next one, we have 540 degrees. Again, converting it to a radian, multiply it by pi, divide it by 180. When you have big numbers, there's a little trick if they all end in 0. They're both divisible by 10. Just wipe the 0 off. And then they're both divisible by, they would both be divisible by 20. Well, what can we divide 54 and 18 by? Chelsea? 18. So if you take 54 divided by 18, it goes in 3 times. So this becomes 3 pi. So 18 times 3 is 54. And then looking at the last one here, negative 1 or 270, converting that to a radian value. So again, the zeros, wipe them off. They have that number in common, just take them off. Sabrina, what would negative 27 and 18 have in common? Yeah, so negative 27 divided by 9 is? 3. And 18 divided by 9? 2. So negative 27 is the same as, bless you, negative 3 pi over 2. So converting from a radian, or from a degree to a radian, we're multiplying by pi over 180. So at the top of the next page, trying to get you to do the opposite, you have a radian. Now we want to get it in degree form. So what do you think you'd multiply by if we want to get it in degree form? Brandon? Yeah, we're going to multiply it by 180 over pi. Pretty much the flip, because now we want to do the opposite. We've got the radian value, we want to get the radian out of the problem. Brandon, what happens with the pi's? They cancel. Gone. The radian part canceled out. And then if we reduce 180 divided by 2, Brandon, you end up with? Yeah, so it's a negative 90 degrees. So 9 pi over 2, pretty large angle, 9 pi over 2. 2 pi is 1 rotation around the unit circle. So we're moving around the unit circle more than 1 time here. So again, doing a little reducing. Harris, we know that pi's cancel. How would 180 be divided by 2? So what is 180 divided by 2? 90. Okay, Harris, how's your mental math today? 9 times 90. What's 9 times 9? 81. Add the 0. 810. So 9 pi over 2 is 810 degrees, which goes around this circle twice and then an extra. So 810. The last one's a little weird because it's just the number 2. And if you look underneath, it says if no units of the angle are specified, radian measure is implied. Implied is a better word, I guess, than saying assumed, because we're not allowed to assume things. You especially learn that in geometry. We're not allowed to assume angles were congruent. You're not allowed to assume sides were congruent. But if you don't have anything listed next to it, there's not a degree sign, it doesn't say radians, the radian is implied to be in the answer. So this is 2 radians, even though it doesn't have a pi next to it. The pi was already placed in there. So some number times 3.14 was calculated together to give us the value of 2 radians. So if we want to convert it to degrees, what would you do? did you do with the other two problems? Brandon? Yeah, you're still gonna multiply it by 180 over pi. Except we're not gonna get a nice answer because we have a pi still in the problem. So if we take 2 times 180, we get 360 divided by pi. I actually want you to divide the pi out of the problem so that we have a degree value to work with. So if you take 360 divided by pi, you actually need to pull out your calculator for a couple problems. What is 360 divided by pi? So it's an angle between 114 and 115 degrees. So it's not a nice exact angle like 810, but that's because we didn't have a nice angle like 9 pi over 2. It was just the number 2. So with radians, when you just have numbers, you don't end up having nice angled answers as a degree. So this is still a degree answer, 114.59, just isn't a nice whole value like the 810 or the negative 9. Questions? Questions with converting from one to the other. So the other thing we're going to talk about today, still looking at conversions, would be a specific angle that's called degrees, minutes, and seconds. So angles work like time. There are 60 minutes in an hour. There are also 60 minutes in a degree, and that's what this part here is saying. So 1 minute is the one little tick mark. 1/60th would be a degree. So 1/60th of a degree would be how we would say 1 minute. So 1 out of 60 minutes are in a degree. 1 second is 1 out of 3,600 because there are 3,600 seconds in an hour. So there are also 3,600 seconds in a degree. So it works just like time. And literally, like, my clock is in the back there. But if you think of a clock, what's the shape of most clocks? A circle. A circle has 360 degrees in it. So the degree values work exactly like time. So it takes 60 seconds for our hand, our seconds hand, to spin around a clock. It's going to be that same information here. So 60 seconds for it to spin around a clock for 1 minute, but it's really 3,600 seconds for it to spin around to get to 1 hour. So that same kind of measurement here. So the question underneath, this is what a degree, minutes, and seconds looks like. The reason we have them is because if we need to be really specific, like in aviation or navigation, you have these specific measurements. And towns, like going back to when you learned about longitude and latitude, like maybe 4th or 5th grade, you did longitude and latitude lines? No? Maybe, you don't remember. If we're giving like a location of a city, and you go on like Google Maps, and you might be able to find the location of a city with degrees, minutes, and seconds. But this is like an exact location of where a city is. So it's 64 degrees, 32 minutes, and 47 seconds. Or it's an exact angle that an airplane needs to fly at. So a little less of a degree, a little more of a degree could make a big difference when we're talking about navigating somewhere. So we want to convert this to degree decimal form or decimal degree form, which is the form that the last answer was in. Because if we're trying to use or apply this to like sine, cosine, or tangent, we can't really use the degree decimal form, or I'm sorry, the degrees, minutes, and seconds. So the first one has here 64 degrees, 32 minutes, 47 seconds. How do you think you try and convert that to a decimal? So like we know this part here is the degree value. So we know we have to have 64 degrees. But the 32 minutes, the 47 seconds, how would we take that and try and convert it to a decimal value? Michael?
Would you have to multiply like the 160 times 32, or like the 1 over 60 times 32?
Yeah.
1 over 3,000.
So he said you take the 32, because it's 1/60th, and the 47, what are we doing that?
Times the 1 over 3,600.
Excellent, 1 over 3,600. Because that's really 32 of 1/60th of a degree. The other way you can think of it is it's 32 minutes out of the 60 minutes in a degree. That would be the same thing, another way of thinking about it. It's 47 out of 3,600 seconds in a degree. So I want to find out what that little portion is. And they need to be added together because they're going to increase our angle by that amount. So it's going to be 64 degrees, but it's a little bit extra because we're moving a little past 64 degrees. So if you take 32 60ths and add it to 47 at 3,600ths. And I'd say we'll try and keep about 3 decimal places here. Chelsea, what do you have? 546. This is still in degrees. We didn't convert it to radians. But now we have a specific degree value. So looking at the second one, we have 125 degrees, 15 minutes, and 29 seconds. So again, it's a very specific angle. But if we want to try and apply sine, cosine, tangent to this, which would be the goal as we work on forward, we need to convert it so that it is in a decimal format. So you're taking the 15, multiplying it by 1/60th, they're thinking that it's 15 seconds out of a total of, 15 minutes out of a total of 60 minutes, or 29 seconds out of a total of 3,600 seconds. So we're kind of like adding that on top of the 125 degrees. What do you have, Chelsea? Questions? So the last conversion, so this is taking a number and placing it into decimal form. So of course we can try and flip-flop that and do it the other way. The last problem with the conversions, for example, 5 wants us to take a decimal value and try and convert it to degrees, minutes, and seconds. So it says convert 0.86492 radians to become a degrees, minutes, and seconds value. So how many degrees, how many minutes, how many seconds would this angle be? So rereading this, convert 0.86492 radians to degrees, minutes, and seconds. What do you think you'd have to do first? Brandon?
Attention students and staff, please be extra cautious as you exit the building today. Our custodial staff has been treating the sidewalks all day, but due to the inclement weather that we are experiencing, there may be some slick spots, so please be careful. Thank you.
Because this is a radian value, we need to convert it to a degree value by multiplying it with 180 divided by pi. Brandon, you know how your calculator. Oh, what did you get there? Give me 2 more because they have 5 decimals up here. 55627. So looking at this number, the first number, the 49, tells us how many degrees there are. So there are 49 degrees. The leftover part would be that extra piece that makes up the minutes and the seconds. So I'm going to take that leftover piece because this is the amount that we're going past 49 degrees. So how do you think we could pull the amount of minutes out of this value? So we have this leftover decimal value that's past the 49 degrees, but how could we figure out how many minutes we would be past 49 degrees? Michael?
Can you divide by 60?
Instead of dividing by 60, because that's technically what we did above. We multiplied by 1/60, so you would multiply by,
60, just regular 60?
yeah, just regular 60. Because we want to put the minutes back in the problem. We don't want to take them out.
I have another interruption, please excuse this. Bus 345 and bus 347 are going to pick students up in front of the building as soon as all the other buses depart. So if you would ride bus 345 or 347, just wait in front of the building and you will be able to load the bus as soon as the other buses have departed. Thank you.
So I have 33 point, is it 3? What's after that? 762. All right, so now we have 33 minutes. And then one last time, we're going to take this extra piece here. 3762. Brandon.
And multiply by 3,600.
Not 3,600 because this is
60
the
again.
60 again. Because this is the leftover piece beyond the minutes. So now we're at 33 minutes, so whatever is left would give us the amount of seconds. And that should be 22.5 something. Is it 22.5? 72. Thank you, Michael. So, using our rules of rounding, 22.5 means we should round up to 23 seconds. So converting is just kind of doing one form versus the other. If you multiply for one thing, you have to divide for the next to get it into the other form. The last example that we didn't get to deals with arc length. This formula is on that formula sheet. We talked about this one yesterday. You'll need that in order to answer the last two problems of your homework. So you might have to peek in your book for that last problem there. A little bit of interruption. Questions? The book homework is not involved. It is a lot of converting from one number to the next. Make sure you have a little bit of work there so I can see how you're coming up with those numbers.
Study the facts.